Hi guys, this time we are going to have a look at a very simple design pattern, yet very powerful one, which name is the adapter pattern. So what this adapter pattern looks like is exactly the same as the adapter in our real life. So let's say if you want to connect, for example, let's say a cable to a port, you need to make sure that that connector exactly fits the port, right? So let's say, I can draw some example here. So let's say you have a port that looks like this. So still remember the enzyme, something that we learned during our biology class. So let's say this is the port. Yeah, this is the port. Then if our connector looks like this, this is the connector. Yeah, wow, horrible handwriting. Okay, this connector cannot fit to the port directly, right? Because the shape is different. So what this adapter does is that it connects between the port as well as the connector. So it will draw the shape, like for example here, like this and here. So by having this adapter at the middle, we are able to connect two, let's say the port and the connector which initially have a different shape. So this is the magic done by the adapter. So in the object-oriented concept, let's say this is the class, and this is the class that utilizes maybe class A, that requires the class A to be implemented. But this is a class B. So class A and class B is different, right? So the adapter acts as something to convert class B into class A so that it can fit into the implementation here. So this is the magic of design adapter pattern. So let's look at the actual implementation. Now we are still sticking to the game concept. Alright. So what I am going to do is that, have a look at this picture. Wow. Okay. So now we have a game which is particularly for Naruto, and we have another game particularly for Bleach. These two are characters from different anime, as well as they are from, assume that they are from different game as well, right? So you want them to be able to interact with each other, to combine these two games into one so that they can fight against each other. Now you need an adapter to ensure that all of them are in the same class. Now let's head to the implementation. So we are going to just focus on the let's say they are going to fight at the Naruto world. So this is the Naruto player, and we have the, so both are from different let's say they are from different games, right? So there's no possibility for both of them having the same parent class. So initially they will have no similarity. So oh my god, what have I? Okay, Naruto player. So I have the HP equals to 10, teacher 10 equals time, Giga magic equals 10, and now I don't know how to spell chakra. Never mind lah. So let's say we'll have a very simple method, which is the attack, and so this is just a very simple method for attack, as well as we have a very simple method to that's all I think. So they will have an attack, and for the Bleach player, despite having the same, so this will return some constant value, let's say 5, the damage is 5. So the Bleach player is having the similar attribute, just that it has the, let's say instead of magic it has a mana. So mana is a similar things related to the magic, but they are having similar terms. So let's say this is something like chakra, I don't know how to spell. Never mind, let's call it magic. So this instead of having the method attack, I will have a slash. So let's say this is a ninjutsu. Never mind. Also, okay, something like this. Yeah. So slash, then return let's say also return a 5. So this is the method for the Bleach player. They look similar, but they are not exactly the same. Right, you still can see like minor difference in terms of the attributes, in terms of the method name. Now we have a world which is the world of Naruto, and they are going to fight here. And I require to use the Naruto player 1 and Naruto player 2. So this is a very simple example which I need 2 players, which is both from the Naruto player class, to be able to initiate a fight. Now I have the it's damn hot. Okay, now this dot player 1 equals to player 1. This dot player 2 equals to player 2. And a simple fight method which will initiate the attack from player 1, then player 2 attack. So let's say instead of HP, they'll have something different, let's say from health. Yeah. So okay. Minus HP integer value HP now this is the minus HP method, which is something like a setter for the HP, but it will only reduce the HP. And this also have lost health, for example this method, and also the same parameter, and the health will be value. So these are the 2 methods needed. So here player 1 dot let's say minus HP with the player 2 dot attack, and player 2 also, so they will hit each other like once. So player 2 also minus HP equals to player 1 dot attack. Now we have our method already. So inside the main method, I will use this Naruto world NW equals to new Naruto world, and here will be new Naruto player. So this is a normal flow for hold on. Okay, so this is the normal class for the Naruto world, which includes 2 Naruto players. This is the, let's say this is a Naruto game, right? So we will compile the adapter pattern first, and adapter pattern dot main. So Naruto player is attacking, Naruto player is attacking. No, I didn't print. Oh damn. Okay. let's say here instead of locale directly, I will integer. I'll return this. So a little bit difference here. So let's say if the Bleach player is a void lost health, whereas the Naruto player will return an integer which is the HP itself. So now I will print the entire thing here. Hold on, I will explain everything later on, yeah? And now setting each other. Alright. Now let's see what will happen. Naruto player is attacking, and this is the HP for the player 1. And Naruto player is attacking, this is the health for player 2. So now we have a fight method which will reduce the HP of player 1 by the attack damage of player 2, as well as reducing the player 2's HP based on player 1's attack value. So I will directly print them out. So let's say this is the HP of player 1, and this is the HP of player 2. Yeah, so that's it. So now we already have 2 Naruto players, but this is not our final target, right? Our final target is to have a Bleach player to play together with the Naruto player. Now, we want them to be able to fight together. What happens here is that because we are dependent on the concrete class itself, so this main method is already like dependent on both concrete class. One is the Naruto world, another one is the Naruto player. So this is not exactly what we want. We need to use an interface like the principle we have mentioned before, the principle that we need to depend on abstraction, not the concrete class. So we'll see why later on. Because of this, so try to imagine now we are depending on the concrete class Naruto player. So in order to the Bleach player to become the Naruto player, you need to actually extend the Naruto player here, and this will mess up the entire Bleach player codes, because once you extend it will inherit the method for the Naruto player, which might not be the desired method for the Bleach game. Now you can see why we have to depend on the abstraction, not the concrete class. What I meant by depending on abstraction is we need to use an interface. So let's say this is the player in Naruto world. So every player in Naruto world will need to implement this interface, and this interface will only have 2 methods. One is integer attack, another one is minus HP. So these 2 are upon the abstraction, so they are the abstract method, right? So this is also the abstract method. And now this Naruto player will implement the players in Naruto world. Definitely, right? Makes sense, right? So now this method will actually do no difference to the Naruto player, except it has the dependency for the interface. So now it's also having these 2 methods, which is exactly the same as the interface does. So I don't have to change anything for this class, and this will not yet implement the player in Naruto world, and it will never be, because this is a standalone player in the Bleach world. What is going to change is the Naruto world here. Instead of depending on the concrete class Naruto player, I will depend on the player in Naruto world instead. So now you can see the use of the interface in terms of the dependency, right? Because you are dependent on this. This 2 is not necessarily be the Naruto player already. Any class which implements the player in Naruto world, they can play in this world already. What is a good thing about this is that it prepares us for the integration between Bleach and Naruto game. Now, you have 2 players that implements the interface, that requires to implement the interface player in Naruto world. Now, here is also valid. We try to run it, it should yield the same result. Right, Naruto player is attacking HP, then Naruto player is attacking HP. Now, we have prepared for integration with our Bleach player. So, now we are going to make an adapter. So this is where the adapter pattern comes into place. This is a currently standalone class, as you can see. Even without the class, everything will work. We have the interface and a Naruto player which implements this interface, as well as the Naruto world which uses these two interfaces. Right, this interface are for these two objects. Now what we are going to do is we are going to create another class which name is the Bleach adapter. So this adapter will play the magic for us. It will implement instead of implements the interface in the Bleach game, it implements the interface from the Naruto world, which is the player in Naruto world. So by using this, you can ensure that this Bleach adapter can fit into our Naruto world, which requires this as an implementation, right? So now we have this Bleach adapter, and it will have a constructor. This constructor will take a parameter which is the Bleach player. So say if we are using the composition to implement the adapter in this case. So Bleach player BP, this dot BP equals to BP. So this Bleach player will become the object which takes the Bleach player as a parameter, and it will do every operation inside by calling this object. What this adapter does is that instead of using these two methods from the Bleach player, it will use these two. Why is it? Because I implement the player in Naruto world, right? So I need to adhere to their rules. So, but the internal implementation will be different. Instead of returning this, I will return the BP dot, let's say, attack. No, I don't have an attack method here, right? So I will use a slash method. So slash is equivalent to attack for Naruto player. So this is from the Naruto world, this is from the Bleach. So once I call the attack in Naruto world, it will call the slash for the Bleach player. Same goes to the minus HP. Instead of using the minus HP, I will use the lost health with integer value. But because of this returning a void, so this is irrelevant in the Naruto world. I need to return the BP dot health. Why is it? They are doing the exact same thing actually, because in the Naruto, right, we will return the HP, but in Bleach we are not returning the HP, so we need to manually return the health. So this will be BP dot lost health. Okay, that's it for our adapter. Well, now it includes a Bleach player as the object. We'll try to call in the main method to see if it works. Now, instead of using the Naruto player, I cannot actually use directly the Bleach player like this. So this is irrelevant because this Bleach player doesn't implement the player in Naruto world interface. So instead of using this, I will use an adapter which is called the Bleach adapter, and it will take a parameter which is the Bleach player. Well, seems like it's working. Now let's try if it works. Yes, now we have a Bleach player attacking, slashing the player 1, which is the Naruto player, and Naruto player is attacking the player 2. So both are successfully integrated with each other. Now, this is a scenario for in terms of the gaming perspective. Yeah, so try to imagine in a, let's say, in a normal software environment, you have a legacy system which using class A, and you have a new system which uses entirely new class A, which is called class B. So in order to integrate the legacy system with the new system, you need to have an adapter, right, to convert the object from class A into a new class B. So this is where the adapter comes into place. Now coming back to this class, so we are still using the composition. So as I mentioned in previous tutorials, whenever you are able to use the composition, yeah, try to be it a good practice to favor the composition instead of inheritance. It can give you more flexibility. Yeah, so it will implement the base class which you are using in the new system, for example. This is from the old system, and whatever method that's required in the new system will be calling the equivalent method in the old system. So both are equivalent. So let's say, for example, if the attack from the Naruto is higher than the bleach one, so in order to make them like balance, maybe you need to do some computation before you call the bp.slash and return the value. Maybe you need to scale up by, let's say 1.5 for bleach player. Everything can be done in the bleach adapter. You are free to choose the behavior when the bleach characters come into Naruto's world. Pretty fun, right? So that's it for the adapter pattern. This is very, very commonly used and very useful as well, right? I hope you can get how it works. Yeah, depending on the interface and using adapter to convert that to having that interface. Yeah, a class which initially don't have that interface, convert it to become something who does. That's it for the design pattern. For this video. See ya. Bye.